Hello and welcome to the Synthesis Week of this MOOC. As the name suggests, in this week we will explore how the things you learned are connected. In this MOOC, we have covered lots of different themes and challenges that are of relevance for sustainable urban development. So far, we have covered these per challenge and theme individually, and we did not look at the linkages and interrelations between them. For example, we did not explore the connections between weeks, such as how digitization of society affects socio-economic transformations in our society. Furthermore, you have heard and seen many solutions that were applied and developed from different perspectives, or what we call themes in this MOOC. So for instance, we looked at renewable energy generation and recovery of resources from urban waste flows. Although we have indicated that links between themes and challenges are necessary, we would like to use this week to emphasize this further. Specifically, we would like to make clear that for sustainable urban development, an approach must be taken that crosses the boundaries of disciplines. This is often referred to as a multi-trans or interdisciplinary approach of working, which means that the analysis of problems and the solutions to problems are not carried out only in a single discipline, such as social science, environmental science, natural science, or engineering, but that rather integration across all these disciplines is required. So let us look at how an approach that links across many disciplines can change the way a problem is perceived and how it is solved. In a number of neighborhoods of Amsterdam, bread was thrown into the water to feed ducks. This was attracting rats and was contributing to pollution of the water body. At first, it was attempted to improve the water quality by taking technical and management measures, such as to change the flow regime of the canals, applying floating gardens and a fountain. Furthermore, the municipality provided bread containers to collect and dispose the waste. But this was a very single-discipline approach and only addressed the observed problem, the poor water quality and the rats. A problem analysis incorporating multiple disciplines resulted in a better understanding of the actual reasons or drivers for the situation and led to a better solution to the problem. An entrepreneur and an artist collective in one of the neighborhoods investigated the reason for feeding animals with so much bread. It turned out that the reasons were the attitudes and beliefs of people in the neighborhood. People did not want to throw away bread into bins, but rather give it to animals for a good cause. After the artist and the entrepreneur understood this, they came up with an acceptable solution that provided a useful purpose for the bread that is directly visible to the community. The solution was to anaerobically digest bread and produce biogas to bake new bread and heat the community building. This solution would have not been discovered were it not for an integration between the natural science discipline, the problem discovery, the social science discipline, the reason for the problem, and engineering, a solution to the problem. There are more formalized frameworks for the analysis of such systemic problems, which can help you to think across disciplines. This is, for instance, the driver, pressure, state, impact, response, or DIPSER framework. Drivers or driving forces are needs of individuals that result in behavioral patterns. For individuals, this may be the need for shelter, food, self-fulfillment, or pursuit of a belief, as was the case in the duck feeding example. Pressures then describe the release of substances or emissions as a consequence of the drivers. In the case of duck feeding, this was the release of nutrients into water bodies. This pressure then causes a state change, which describes the environmental condition, for instance, in terms of concentrations of substances or ecological classification. In the present case, this was water pollution with nutrients from the bread, so-called eutrophication. This state change then has impacts on the social and economic functions, such as the provision of adequate conditions for health and biodiversity. In the present case, this was eutrophication that caused algae blooms and pests such as rats. Finally, responses are then the actions and solutions implemented. They can tackle each part of the cause-effect chain of drivers, pressures, state, and impact. Responses that address drivers are often related to the social science discipline, while responses related to the impact are engineering or natural science based. In the present example, the solution was implemented to reduce the pressure. It was an anaerobic digester. So, in this week, you will look at a number of examples and real cases where disciplinary boundaries are crossed. You will see that this sort of approach helps to solve urban problems and to identify win-wins, because it ties together multiple sectors, actors, and perspectives. Indeed, this is the idea of AMS education, and in this week we will give you more insight into how transdisciplinary approach of AMS looks like. So, are you ready to take on the challenge of interdisciplinary sustainable urban development?